first, what do you need for the project? You're going to need 13 different wires. Obviously, you're not going to be buying the wire itself. What we're going to do is you're just going to pick 13 different wires. They have to have different types of sizes, insulation type, or core type. So, for example, you could have number 12 THHN solid, number 12 THN stranded, number 12 TW solid, number 12 TW stranded. That would have been 4 wires right there. So we're not going to cut the wires or strip them, so we'll go on through that. We're not going to measure them with the micrometer. But when you do your chart, I want you to start with the smallest wire on the top and the largest wire on the bottom. So as you can see, as the numbers get smaller, the wire gets larger. So number 10 is greater than number 14, and so on. You're going to be filling out your chart from the code book. So let's take a look at the chart. Okay, so for example, this is number 2, American wire gauge, AWG. So number 2 goes there, it's on the wire itself. We're not going to calculate the circular mils, but if you were, what you would do is you would measure the wire with a micrometer, you'd multiply the reading by 1,000, you would square that, and multiply the number of strands, and you would get the circular mils. So here's an example of 0.098. Multiply it by 1,000, we get 98. We square it, 7 strands, and we come up with the actual circular mils for that wire. Also, you're going to find the circular mils that are in the code book. So right here is all the circular mils up through 4/0. And you notice after 4/0, there's no circular mils listed. Because after 4/0 is the largest wire on the American wire gauge. And after that, we have 250 kc mil, which in essence says it's 250,000 circular mils. So it's already given to you there. Back in the day, we used to call this MCM. Does anybody know why it was MCM instead of kc mil?
KC and the M, it stands for milli, huh?
No, okay, so the M in MCM is, M is 1,000 in Roman numerals. Someone I think said that. So when we said MCM, it was 1,000 circular mils is what MCM stood for. But they've updated it now and they call it kc mils. So you'd find all that in table 8 and you put in the answer for the size of the wire. Then the number of strands is also in table 8. Now you notice after number 8 wire, all the strands are stranded. And in fact, in the code it says after number 10, it has to be stranded wire. So I don't even think you can find 8 solid around anymore. And then the letter code would be the THHN/THWN. T is for thermoplastic. H is the heat factor, so if there's no H, it's 60 degrees. 1H is 75, and 2H is 90. And you can see here it's 90 degrees C wire because it's got 2H. The W is for wet location and it's for nylon. Then for the insulation, you go here and it's It's just easy if you make some type of a, what would you call it, a key. So instead of writing flame retardant heat resistant thermoplastic, you got one that's for flame retardant and then 2 stars for heat resistant thermoplastic. So you just have to put that on the bottom of your table. And then the insulation thickness is still on table 310.104A. So you can see here, it is 40 mils thick. And then you have the max operating temperature and voltage. So all your wires are going to be 600 volt. Just make it simple because that's what they're going to be, unless you pick out some kind of crazy high voltage cable. Max operating temperature. Again, if it's THHN and you can make it all THHN, it'd be 90 degrees C. If you have THW, it'd be 75. And if it was TW, it would be 60. Then you have your conductor properties, ohms per 1,000 feet. We use the coded ohms. So if you look here, coded ohms per K feet, and you would put that in there. And then your ampacities, when you do the ampacities, use the 60-degree column. The 90-degree column ampacities are strictly for wire derating purposes only, because it's kind of like if you have a chain, let's say, and every link on the chain is rated for 1,000 pounds, but one link is only rated for 500. How much is the maximum you could lift with that chain? It would be 500. Same thing with this is, with the 90-degree column, the numbers don't fit for the application of the wire because, for example, number 12 should only be at 20 amps, but you can see here that number 12 wire at 90 degrees is started at 30. That's because we derate. And the whole thing is like I said with the chain, it's everything on the circuit has to be rated for 90 degree. And there's no such thing as a 90-degree circuit breaker. The biggest circuit breaker out there, highest rating is 75. So there's some locations where it uses the 75-degree column, but for purposes of this exercise and project, just use the 60-degree column for all your ampacities. So there, the number 2 would be 95 amps. And then you look here, there's asterisks here, and pretty much that's when you refer to 240.4D, it's going to tell you that number 14 can't be more than 15 amps, number 12, 20, number 10, 30. And that's what you see right here in the 60-degree column. So again, just use the 60-degree column. And then applications and provisions is on table 310.104A. And again, dry and damp locations, you can, instead of writing it all out, you can make some type of symbol to represent it. And that's really it for what we did here with number 2. Obviously, we didn't calculate the circular mills because I don't expect you to buy a $100 micrometer and then buy all the wire. So we'll just get the circular mills out of our table, out of our code book, table 8. Number of strands, letter code, there's your provision, there's the legend down at the bottom. So if you're going to if you're gonna abbreviate something with symbols, make sure that you have a legend that tells me what those symbols mean. Any questions on how to fill out the chart?
Everything's in the book, correct?
Everything's there, just like I showed you. If you just go through this PowerPoint, it'll tell you where to go in the book to find all the information.